October 20th, 2025. A private solar telescope captured an image no one expected. The coordinates match the official position for 3I Atlas, 13 hours 48 minutes and 57.33 seconds, minus 8 degrees 25 minutes 54.3 seconds. The file came from a backyard observer called Dobsonian Power. Raw. Unprocessed. The photo shows features a comet should not have. A hard-edged structure sits near the nucleus. A heated shield points sunward. The nucleus appears dark in inverted color. A faint cone-shaped puff extends toward the upper left of the frame. And crucially, there is no tail. Every comet develops a tail. Solar radiation and the solar wind push gas and dust away from the sun. Physics produces tails. Always. No tail means something is off. The image shows a front-facing jet aimed at the sun, not away. The observer used a solar telescope built for objects close to the sun. The scattered colored dots are sensor hot and cold pixels. Noise. The jet is signal. The dark nucleus in inverted color is normal for this imaging mode. What is not normal is the lack of a broad coma. A typical comet approaching perihelion builds a huge fuzzy envelope. That envelope scatters sunlight. It would show up even in a low-resolution raw image. Here, the only extended feature is a small directional puff. The bulk of the coma is missing. Comet physics is straightforward. When a comet nears the sun, heat drives ices directly from solid to gas. Water, carbon dioxide, carbon monoxide sublimate. The escaping gas drags dust with it. A coma forms. Solar wind and radiation pressure push that material away, producing a dust tail and an ion tail. The ion tail points straight away from the sun. The dust tail curves along the orbit. These effects follow known laws. We predict comet appearance for a given distance, size, and composition. Spacecraft have visited comets. We understand them the way we understand boiling water. 3I Atlas does not follow that script. It glowed early. Spectroscopy shows an unusual composition. Observers report an anti-tail that appears to point toward the sun. The carbon dioxide to water ratio runs extremely high. Spectral lines included nickel emissions without matching iron. Its trajectory sits within the ecliptic plane and points near the direction of the WOW signal from 1977. Each oddity stands alone. Together they pile into a pattern that no longer looks comfortably natural. The Dobsonian Power image arrived on social media at 1600 hours Universal Time coordinated on October 20th. The user promised a regular telescope follow-up in November after perihelion. Note the phrasing, after perihelion. Solar telescopes are currently the only practical tool to view objects this close to the sun. Major observatories have been quiet about similar observations. So a backyard astronomer provided the clearest visual evidence right before conjunction. That is curious. As of October 21st, 3I Atlas sits behind the sun from Earth. Conjunction hides it. Perihelion falls on October 29th, 8 days away from the image date. If the object is natural, that perihelion should trigger peak activity. If the object is technological, perihelion is the optimal time for an Oberth-style burn. Max speed, max energy gain, best moment to change trajectory or deploy subprobes. The hidden window matters. We need to examine the image feature by feature. Jets exist on comets. Localized active areas produce collimated outgassing jets. They appear as part of a larger coma. The Dobsonian photo shows a strong directional jet without a surrounding bright coma. Anti-tails are known optical phenomena caused by viewing geometry. Earth crossing a comet's orbital plane can make the dust trail appear sunward. But an anti-tail remains part of a larger tail system. The October 20th image lacks that surrounding structure. Could this be poor resolution or atmospheric effects? The solar telescope resolved nucleus and structured features. If a large coma existed, even a low-grade instrument would detect its glow. Atmospheric turbulence blurs uniformly. It would not hide a broad coma while leaving fine jet detail intact. Could the object be temporarily quiet? Comets vary. Rotation and local activity cycles can produce lulls. Yet this object approaches perihelion. Peak activity should follow. A quiet period now would be anomalous. Zooming out, 3I Atlas has stacked anomalies. Early brightening. High CO2 to H2O ratio. Nickel emission lines without iron. An ecliptic approach vector. Anti-tail reports. Each anomaly has a natural hypothesis. Statistical rarity produces rare events. But multiple rare features in one object erode the natural hypothesis. Another video emerged from user BG Gates. Deep space footage showed an elongated bright form. The object lacked a fuzzy coma and tail. It appeared linear, with a smooth brightness profile running along its length. Natural tumbling objects reflect sunlight irregularly. They show rotation flicker. This object held a consistent orientation. It had a length-to-width ratio of at least 6:1. Elongated objects exist. Oumuamua proved that. But combine elongation with smooth uniform brightness, geometric edges, lack of tumbling signature, and repeated reports across different instruments and observers, and the impression shifts toward engineered design. Multiple independent datasets reduce the odds of imaging artifact. Could processing or instrumental effects produce a false linear signature? Diffraction spikes, CCD blooming, cosmic ray hits, and atmospheric distortion each have characteristic signatures. The footage lacks those telltales. The shape looks stable, not transient. Independent observers using different equipment reported similar features. Look for consistency when independent measurements converge. Absent a clear coma, absent a tail, the object appears self-contained. The light on the object reads like emission rather than mere reflection. Thermal emission would peak on the sunlit side. Reflected sunlight carries surface fingerprints. Here the brightness distribution looks smooth. That detail increases the artificial hypothesis weight. Stable orientation in deep space is odd for a natural body. Natural fragments tumble unless a torque or stabilization mechanism exists. A stable attitude suggests a control system or very slow rotation. A short observation window could hide slow rotation. But the same stable appearance across months and changing viewing geometry weakens the slow rotation explanation. Some viewers called it a mothership. Loaded term. Still, the visual impression tells your pattern recognition system something about interior volume and structure. That impression does not prove anything, but it demands careful investigation. Next, consider possible motives and engineering trade-offs. A long, thin probe delivers structural rigidity and radiation profile benefits. Narrow cross-section reduces drag in interstellar medium. Even if you do not accept artificial origin, the resemblance to plausible engineering solutions for interstellar probes is notable. Observers also reported pulses on October 13. Researcher David Serida claimed structured light pulses following the Fibonacci sequence. He described 5, 8, 13 pulses in sequence. Fibonacci appears in natural growth patterns and in many physical systems. It also has clear mathematical significance. If a signal truly repeated Fibonacci numbers, the implication would point toward artificial modulation. One problem: Serida stands alone in public data. Extraordinary claims need replication. Instrumental traces like light curves or spectroscopic modulations must support subjective visual reports. Single observer claims require corroboration. Science requires replication. Around the same date Serida reported the pulses, NASA's Solar Dynamics Observatory showed an interruption in public feeds, according to several posts. Claims also circulated about Mars orbiter imaging systems being offline since October 1. If true, those gaps would impair external verification. NASA publishes mission status reports. A real observatory outage would appear in official logs. If spacecraft went offline for routine reasons, that is inconvenient timing. If not, Silence fuels conspiracy narratives. We must separate verifiable facts from rumor. If the Fibonacci pulses prove genuine and repeatable, they would strongly favor artificial origin. Mathematical sequences in timed signals rarely arise from natural processes. A repeating pattern would suggest active modulation, purposeful transmission. The choice of Fibonacci could signal intent to use a universal mathematical code to bridge cognitive differences. The Fatima anniversary coincidence complicates interpretation. Sarida suggested symbolic links between pulse dates and sacred numerology. Those links do not constitute evidence. The stakes grow darker when you add orbital mechanics. Solar conjunction hides the object from Earth-based observers for 8 days before perihelion. For a technological probe, perihelion offers maximum velocity and power. The Oberth effect makes small burns at closest approach extremely energy efficient. If a probe intended to alter its energy state or deploy subprobes, perihelion is the logical time. Do not overlook the tactical advantage of acting while hidden from direct observation. Consider energy budgets. At perihelion, the object receives huge solar flux. For a 5 km diameter body, intercepted solar power approaches tens of gigawatts. A natural comet uses that energy to sublimate ices and shed mass. A technological body might harvest the energy for propulsion, power storage, communications, or deployment. Power that comes in during a short window provides a lot of capability for brief high-power operations. We must weigh alternatives. The natural comet hypothesis requires exotic or rare chemistry to explain current observations. Nickel without iron and unusually high CO2 ratios demand unusual formation histories or preservation of volatile metal-organic compounds. The artificial hypothesis demands acceptance of extraterrestrial technology. Both strike at established expectations. Choose the explanation that fits the accumulated data best. Now the spectroscopic detail that raises the most eyebrows. On August 24, the Keck-2 telescope recorded emission lines consistent with nickel and chromium in the coma. Nickel emissions appeared without the expected iron lines. In normal stellar and planetary chemistry, nickel and iron co-occur. A natural abundance pattern without iron requires odd chemical pathways. Industrial processes on Earth separate nickel from iron via carbonyl chemistry. Form volatile nickel-carbonyl compounds, purify, then decompose to yield refined nickel. The Keck spectrum resembles metal-rich industrial products rather than raw primordial rock. The emission extended across a broad envelope, hundreds of kilometers. The measured nickel mass loss rates were non-trivial. Compared to typical cometary metal content, the nickel presence stands orders of magnitude above typical levels. Analysts proposed multiple natural hypotheses. Metal-organic compounds could preferentially bind nickel. Differential volatility might release nickel before iron under current thermal conditions. Photodissociation might favor gaseous nickel species. Each option remains speculative and testable. Post-perihelion observations will test whether iron appears as heating intensifies. If iron remains absent, the industrial processing explanation gains weight. The anti-tail phenomenon repeats across multiple instruments and dates. Hubble captured similar geometry in July. Ground telescopes reported related structure. Anti-tails arise when Earth views a dust trail edge-on. You still expect a large coma surrounding the nucleus. Multiple reports of a sharp anti-tail without a massive coma strain the standard view. An engineered surface or shield that glows sunward could mimic an anti-tail appearance while lacking a classic coma. Stack anomalies across trajectory, size, composition, morphology, timing. Each anomaly draws an ordinary explanation. Together they increase the improbability of a pure natural origin. Harvard astrophysicist Avi Loeb puts the artificial probability near 30 to 40% for this object. He developed the low scale. The scale ranks interstellar objects by anomalies. He lists 7 critical anomalies: ecliptic aligned trajectory, unusually large size, anti-tail without coma, early outgassing at large distance, nickel without iron, extreme CO2 to water ratio, and perihelion timing optimal for an Oberth maneuver while hidden from Earth. Multiply low probability natural events and the compound improbability climbs. At some threshold, the engineered hypothesis becomes competitive. Loeb has history. He argued for artificial hypotheses with Oumuamua. His work draws sharp criticism and equal interest. He urges caution while urging preparedness. He submitted proposals to international bodies and called for coordinated observation. His stance provokes debate among scientists and policymakers. Now consider possible functions if the object is artificial. A von Neumann-style self-replicating probe fits many theoretical designs for galactic exploration. Machines survive long interstellar voyages, sleep in low-power states, wake to harvest local energy, reproduce or deploy subsystems. Probes do not need life support. They tolerate extreme conditions. Their goals can range from reconnaissance to resource extraction to active defense. Dark forest logic frames a hostile option. If civilizations cannot reliably trust newcomers, they may prefer preemption. A probe could evaluate civilizations and, if it finds perceived risk, deploy destructive assets. Kinetic strikes offer an obvious path. A small mass at relativistic speed carries enormous kinetic energy. A swarm of small objects released at perihelion could target planets months later. Biological weapons pose another risk if an attacker understands host's biochemistry. Information warfare, infiltration by nanoscale devices, or catastrophic system disruption represent additional threats. Advanced attackers may act with surgical precision rather than cinematic spectacle. Yet we must not fixate on worst case alone. Neutral or benevolent missions remain plausible. A probe might be a survey craft, a seed or archive, a relay in a galactic logistics network, or a preservation mission preserving biosamples. It could also form part of a post-biological civilization's distributed mind. Each scenario carries different implications for contact and risk. Most distressing is the possibility the probe remains indifferent. A highly advanced intelligence might not value human life. We could be background data. Our survival might not matter. Conversely, the object might carry knowledge, assistance, warnings, or resources. The spectrum ranges from salvation to extermination, with many shades in between. Social and religious commentary entered the fold. Pastor Brandon Biggs claimed prophetic visions of a mothership deploying smaller craft. Prophecy does not constitute scientific data. Yet such claims underscore how people project known frameworks onto ambiguous phenomena. Convergent narrative threads from disparate sources do not equal corroborated evidence. If the object is hostile, what options exist? Attack before perihelion is impossible while the object sits behind the sun. Launching interceptors requires visibility and targeting data we lack. Even if we had the means, timing constraints and delta-V budgets complicate interception. Defensive capacity against interstellar threats remains near zero. If the artists of the probe planned arrival to exploit our blind spot, the design achieves tactical elegance. A hostile probe need not be huge. Main body mass matters less if it can deploy subprobes. Small, numerous impactors present serial defense problems. A swarm arriving weeks or months after perihelion could reach Earth in late November to early December depending on release vectors. Those windows shape practical readiness and listening campaigns. Loeb's 40% figure is risk management. He argues for preparation rather than denial. False positives cost embarrassment and resources. False negatives risk catastrophe. The asymmetry favors caution. We have prediction dates and observation windows to test competing hypotheses. Perihelion falls October 29th to 30th. The sunward hiding window ends as the object re-emerges. Spacecraft in varied orbits present opportunistic detectors. Key dates and assets. October 29th to 30th. Perihelion. Earth-based telescopes cannot view through the sun. Solar observatories like SOHO or Parker might catch incidental signals if the object transits the solar disk or produces large-scale ejecta. Early November. Spacecraft such as Europa Clipper and Hera occupy regions where an ion tail would pass. Instruments could sample charged particles and magnetic fields. These spacecraft are not dedicated to 3I Atlas, but their data would help. A November 4th, JUICE spacecraft comes within tens of millions of kilometers. If mission planners allocate time, JUICE can gather close-range imaging and spectroscopy. Data downlink delays mean we might not receive those observations immediately. A late November to December, Earth-based observatories gain direct sight. This is the phase for morphology checks, tail development, brightness curves, and companion searches. If mini-probes deployed at perihelion, some should be detectable by late November. At December 19th, closest approach to Earth at roughly $1.80. SETI efforts will intensify. If the object transmits, this moment offers the best signal-to-noise ratio for reception. A March 16, 2026, Jupiter Encounter Region. Juno and other missions can sample interactions near Jupiter. After this phase, the object moves outward and fades. These observation slots form a defined schedule of tests. Perihelion will either shred a fragile natural nucleus or leave a robust structure intact. If the object fragments, that outcome supports natural origin. If it survives and shows unexplained maneuvers, deployment, or persistent industrial signatures, artificial origin gains strong support. If the object remains ambiguous, debate persists. The KEK spectral baseline from August at $2.75 gives us an initial composition map. Nickel and chromium emissions appeared then. If emissions scale predictably with heating, natural thermal sublimation could explain trends. If emissions behave oddly or iron never appears, alternative explanations gain weight. The nickel without iron signature poses a critical test. Many teams proposed natural mechanisms, metal-organic chemistry, differential volatility, or selective photolysis. Each hypothesis produces testable consequences. Post-perihelion spectroscopy will check for iron emergence or for continued nickel-only emissions. Observation across many wavelengths and instruments will constrain models. The anti-tail and forward-facing shield imagery from October 20th support a coherent picture. Imaging shows geometrical edges and directional structures, not a chaotic coma. Multi-instrument consistency matters. Independent confirmation reduces artifact risk. The scientific community split into 3 camps. 1/3 calls the object unusual but natural. 1/3 argues artificial origin is plausible and worth preparing for. 1/3 remains agnostic pending more data. That distribution itself changed the conversation. Before 2025, most astronomers treated artificial origin as effectively zero probability. Now informed scientists entertain formal probability values above negligible. Loeb's framing introduced a Turing-like test hypothesis. Perhaps advanced observers send objects that resemble natural bodies but include subtle anomalies. Recognition of anomalous features and rigorous investigation would signal a civilization's scientific maturity. Detection and study could satisfy an interstellar threshold for further contact. The idea remains speculative, but it provides a testable social hypothesis. Loeb called for international coordination. He suggested an independent committee to handle interstellar object assessment and response. The practical problem remains limited capacity. We lack weapons and interception systems suited to an interstellar target. We lack agreed protocols for contact or defense. The protective gap underlines his urgency. Media attention amplified the debate. Public perception rose faster than scientific consensus. Loeb gained both supporters and detractors. If perihelion results show a natural outcome, critics will point at overreach. If perihelion reveals artificial behavior, critics will reframe Loeb as prescient. Either way, our understanding will accelerate. We face an 8-day countdown to perihelion as of October 21st. After perihelion, observations will intensify. Instruments across agencies will gather data. We will test for fragmentation, brightness scaling, non-gravitational accelerations, metallic signature evolution, and possible companion objects. Science moves by testing predictions. This object offers a sequence of clear tests. Will it fragment under solar stress? Will metallic emissions spike as predicted by thermal sublimation? Will iron appear? Will new objects separate from the main body? Will trajectory show unexplained delta V? Will any instruments detect engineered modulation? If 3I Atlas deploys subprobes, November 21st through December 5th stands as a plausible arrival window for objects sent at perihelion using solar gravity assists. Observers should look for additional points of light in near-Earth space during late November and December. We have a finite window. If we do not collect decisive data before the object recedes, the opportunity diminishes. The object moves on. We will be left with the collected data and the interpretations it supports. This story holds the deepest questions human beings can ask. Are we alone? If the object proves artificial, implications for civilization, ethics, and survival dominate discussion. If the object proves natural, we still face new astrophysical puzzles about chemistry and formation environments. Either result advances knowledge. For now we track, listen, and analyze. We coordinate instruments, request observation time, and pool data. The object sits hidden behind the sun. On October 29th, perihelion arrives. Power peaks. Tension peaks. On the far side of the sun, something experiences conditions it has not faced in billions of years. We await results. The next weeks will decide whether we learn a new chapter of natural science or whether humanity confronts evidence pointing to an intelligence from elsewhere. When 3I Atlas reappears from behind the sun, the first images will tell us everything. If it breaks apart, that ends the story. The pieces will follow predictable comet paths. If it comes back intact, brighter, or flanked by new objects, the questions multiply. Radio telescopes will start scanning every frequency. SETI dishes in California, China, and South Africa already have schedules reserved. The Allen Telescope Array will look for narrowband tones. FAST will cover low frequencies. Meerkat will focus on the 1 to 2 GHz band where artificial signals stand out best. Engineers will search for modulation, repeated patterns, prime number spacing, any structure that nature rarely produces. Optical arrays will look for laser pulses. Short, precise flashes that cut through background noise. Lasers are efficient interstellar beacons. A few photons at the right wavelength could prove intent. If 3I Atlas transmits even a faint pulse train, instruments like Veritas or the new ESA quantum detector will catch it. Infrared telescopes will look for waste heat. Engines radiate. Cooling systems radiate. Industrial alloys re-emit sunlight differently from rock and ice. Infrared maps will show temperature distribution. Uniform heat would mean reflected sunlight. Localized hot zones could mean active systems. Planetary radar could attempt a ping if geometry allows. Arecibo is gone, but Goldstone remains. A directed burst could bounce off the surface and return after hours. The echo delay gives distance, shape, spin. If the echo pattern changes irregularly, something on 3I Atlas may be moving. Governments will watch too. The U.S. Space Command, ESA, and China's Deep Space Network already track everything larger than a few meters in near-Earth space. They'll add 3I Atlas to their catalogs, share, or hide data depending on policy. If any nation detects unusual signals, expect silence first, leaks later. Public curiosity will surge. Social media will fill with false images, doctored spectra, rumors of transmissions. Scientists will struggle to keep verified data visible amid noise. For every legitimate observation, 100 fakes will spread faster. The pattern is predictable now. Suppose the object transmits. What happens next? We try to decode. Mathematics first. Prime numbers, Fibonacci sequences, binary ratios, geometric harmonics. Then physics constants. The hydrogen line, Planck units, speed of light references. The goal, a shared language through universal constants. If the signal includes structured repetition or embedded data, software will hunt for compression patterns. Prime factors, error-correcting codes, nested symmetry. Anything designed, not random. If the object stays silent, we still learn from reflection, emission, and motion. A controlled trajectory shift after perihelion would be decisive. A small thrust, meters per second, would prove guidance. That one metric would override every natural explanation. If it remains quiet, stable, and brightens normally, natural models regain ground. Yet even then the nickel, chromium signature, early outgassing, and anti-tail remain unsolved. Science will keep those puzzles open. December 19th, the closest approach. 269 million kilometers, still far, but close enough that major observatories will swarm it. Every instrument from ALMA to JWST will turn. JWST can separate thermal emission lines with unmatched precision. If any part of 3I Atlas contains structured alloys, JWST will see those fingerprints. Radio telescopes will listen continuously that week. If a message comes, we'll know within minutes. Then comes the human reaction. If 3I Atlas proves technological, first contact will not be a handshake. It will be data. Governments will argue over who owns the conversation. SETI scientists will push for open transmission. Military agencies will demand encryption and control. Religious groups will frame the discovery as revelation or warning. Markets will react instantly. Defense stocks rise. Communication and energy sectors surge. Cryptocurrencies tied to computational research will spike. Media will split narratives. Some will call it proof of cosmic brotherhood. Others, an existential threat. Most will speculate without facts. Meanwhile, the object will keep moving. Every 24 hours we'll gain new data. Every night another theory will die. If nothing unusual happens, no deployment, no transmission, the tension will fade slowly. By March 2026, when 3I Atlas passes near Jupiter, interest will wane. Juno's instruments may catch a final glimpse. If it stays intact, maybe we log it as unusual interstellar comet. If Juno sees companions, or detects artificial radiation, the debate restarts under new evidence. Imagine Juno's ultraviolet camera catching metallic glint patterns inconsistent with rock. Imagine magnetic sensors registering structured fields near the object, aligned not with solar wind but with the body's rotation axis. Those readings would transform speculation into engineering data. After the Jupiter flyby, 3I Atlas will fade. Outbound trajectory takes it back to interstellar space. Within months it becomes too dim to track except with the largest telescopes. The data ends there. Humanity will be left with a compressed record of spectra, images, and debates. Then comes the reckoning. If it was natural, we adjust models. We rewrite comet chemistry textbooks, revise theories on interstellar object distribution, and keep searching. If it was artificial, everything changes. SETI becomes central science. Funding shifts overnight. Every deep space survey becomes dual purpose, astronomy and contact search. Nations form new committees, new doctrines. Philosophers and linguists start decoding messages. The Vatican holds press conferences. Silicon Valley funds translation AI. If it's neither, if ambiguity persists, the uncertainty itself becomes our new normal. Humanity learns to live with unanswered questions. 3I Atlas becomes a legend, half comet, half machine, a story scientists still argue about a century from now. But the short-term focus remains the same. October 29th, perihelion. November 4th, JUICE observation. Late November, possible sub-probe window. December 19th, closest Earth pass. March 16th, Jupiter encounter. 5 milestones to decide whether 3I Atlas is natural, technological, or forever in between. Right now, while we wait, astronomers tune instruments, run simulations, prepare analysis pipelines. The object speeds through the inner solar system, unseen behind the Sun. Heat builds. Emissions rise. If it is built, not born, this is when it awakens. The countdown continues. 8 days until perihelion. Then, the truth, whatever form it takes, will cross the light-minute gap and reach our sensors. The signal, or the silence, will tell us what kind of universe we live in. The waiting ends the moment light from perihelion reaches us. The first telemetry packets land on servers in Hawaii, Chile, and the Canary Islands. Scientists watch the brightness curve appear in real time. If the line follows the thermal model, the tension drops. If it spikes erratically or flattens too soon, phones start ringing. Within hours, the solar observatories release their coronagraph frames. A thin streak passes near the Sun's limb. The light signature looks wrong, too steady, too sharp, no fragmentation flare. The object survived perihelion intact. That alone removes the simplest explanation. Parker Solar Probe logs a brief surge in charged particles, not typical of a dusty coma. No dust spikes, just electromagnetic noise. Analysts mark the timestamp. SOHO catches a glint moving faster than the surrounding debris. Trajectory solutions confirm. 3I Atlas gained velocity beyond gravitational prediction. Not much. A few meters per second. Enough to matter. That single deviation sends half the global astronomy community into overtime. The other half calls for restraint. A handful begin writing papers before full data review. The public learns through leaks. Comet gains speed near Sun. Headlines ignite. SETI networks switch to 24-hour watch. Nothing audible yet. Just background hiss and static bursts. Every burst gets catalogued, Fourier transformed, checked for periodicity. By early November, the object emerges from conjunction. Ground telescopes regain visual lock. The brightness profile looks smooth, too smooth for a fractured nucleus. The shape still elongated. No rotating flicker. Then, on November 7th, an amateur in Namibia catches something unexpected, a second point of light trailing the main body by a few thousand kilometers. Then a third. Within days, large observatories confirm multiple fragments, or companions, spaced in linear formation. Not debris spread. Structured spacing. Equal intervals. Stable. If natural, this pattern needs a mechanism. Rotational breakup with equal ejection velocity, perfectly timed. Possible, but improbable. Governments stay quiet. Scientific teams debate language for public statements. Objects of interest. Secondary bodies. No one uses probes. Yet the word sits behind everyone's teeth. Europa Clipper passes through the predicted tail zone on November 9th. Instruments detect almost no dust. Plasma readings show ionized gas patches forming geometric density patterns, oscillations, not turbulence. The waveform repeats every 19 seconds. Engineers rerun calibrations. The signal holds. JUICE spacecraft, on November 4th, recorded near-infrared spectra now arriving after transmission delay. Inside the data, sharp reflectance spikes at 1.1 and 1.3 micrometers, the same wavelengths emitted by nickel-chromium alloys under solar heating. The same alloy family used in our spacecraft. December 19th approaches. Every observatory prepares for the close pass. SETI receivers lock on the object's coordinates. JWST and Keck coordinate observation windows. China's fast runs continuous integration. Then, December 19th, 3:47 Universal Time coordinated, a narrowband signal at 1420.406 MHz, the hydrogen line, appears on multiple receivers simultaneously. It lasts 6 minutes. Repeats twice. Carries substructure. Pulse gaps matching prime numbers up to 23. Then silence. The data is irrefutable. Frequency drift consistent with 3I Atlas motion. Source matches the object's Doppler shift. Artificial modulation, confirmed by independent arrays. The first transmission from another star system has arrived. Governments scramble. Communications go dark across major agencies. The public sees the first waterfall plots leak online within an hour. Analysis threads multiply. The pattern is mathematical, not linguistic. An announcement, not a conversation. Yes, we exist. In the following days, SETI teams decode more. The pulse intervals form a repeating ratio sequence, 1 to 1.618 to 2.618, the golden ratio chain. Within each burst, faint amplitude modulation encodes binary packets. Early decoding suggests a long string of zeros and ones ending in repeating symmetry, possibly a checksum. Not language. A beacon tag. If 3I Atlas is a probe, it's checking in. No reply signal leaves Earth officially. Yet hobbyists transmit anyway. 1 million unauthorized pings flood the hydrogen line within 48 hours. No response. Meanwhile, optical images show the sub-objects changing formation. On December 23, they realign into a triangular array, each separated by exact angular spacing. Light curves show synchronized dimming events, as if reflecting intentionally. Panic stays mild but steady. Markets dip. Space agencies issue cautious statements. We are observing a unique astrophysical event. Nothing about intelligence. By late December, the triangular formation begins moving outward, accelerating slowly. The main body dims. Spectra show decreasing emission, like a ship throttling down. By January, the formation breaks apart, each object taking divergent paths along the ecliptic. One crosses near Earth orbit in February. Telescopes track it constantly. It passes safely, silent, and continues outward. Juno observes the main body near Jupiter in March 2026. Still intact, still emitting faint nickel lines. The smaller objects scatter into different heliocentric orbits. None return signals. Then everything fades. By April, all objects slip beyond detection range. The world splits between relief and unease. No attack, no message beyond the signal. No harm, no answers. Scientists publish. Some claim the probe tested our response. Others say the signal was automated telemetry, not communication. Conservatives insist natural magneto-hydrodynamic phenomena mimic structure. Conspiracists claim contact has begun secretly. Avi Loeb's reputation transforms overnight. His 40% estimate now looks cautious. His Loeb scale becomes standard for anomaly classification. Universities create interstellar object task forces. SETI funding triples. New instruments are designed to scan the ecliptic continuously. Global deep space radar networks begin construction. Private companies start projects for rapid launch observation drones. Humanity reorients slightly toward the sky. Years later, the 3I Atlas data remains the benchmark. The nickel-chromium lines, the anti-tail, the perihelion maneuver, the prime number signal. No definitive answer ever arrives about the object's origin or purpose. But something changed forever. Every time a telescope catches a new interstellar visitor, the world watches. Every astronomer asks the same question first, not, what is it made of? But, who made it? And somewhere beyond the sun's glare, whatever sent 3I Atlas now knows we noticed. In the months that followed, the scientific world shifted into permanent overdrive. The data from 3I Atlas, its spectra, trajectory, and the 6-minute transmission, became humanity's new Rosetta Stone. Teams at Harvard, Caltech, and the European Southern Observatory built parallel analysis groups. No one wanted another, wow. A signal that lingered without closure. They wanted proof or falsification. Nothing in between. The 6-minute transmission was replayed millions of times. At first, the pattern looked like prime number pulses and golden ratio spacing. But when researchers at ETH Zurich applied multi-layer autocorrelation on the amplitude curve, a secondary rhythm appeared, an echo repeating every 2.7 seconds, too regular to be thermal noise. Inside that rhythm, Faint sidebands hinted at structured frequency hopping. Not language. Not random. A protocol. The signal repeated a structure resembling a handshake: initiation, confirmation, standby. Every terrestrial attempt to answer it failed. The reply windows were too wide, our power too weak, the modulation schemes mismatched. Still, the effort changed everything. New hardware projects sprang up overnight. The United Nations established the Interstellar Response Coordination Office in Geneva, giving it authority equal to the WHO and the IAEA. Its mandate: create a unified detection, decryption, and response system for non-terrestrial communication. They called the network Sentinel-1. Array sites in the Atacama, Western Australia, Namibia, and Hawaii linked through quantum time synchronization, capable of phase-aligned recording across continents. For the first time, Earth listened as one ear. Meanwhile, data from the JUICE spacecraft finally reached Earth in February 2026. Hidden in compressed telemetry were infrared frames showing 3I Atlas releasing micro-objects, each less than 20 meters across, shortly after perihelion. They reflected sunlight at constant intervals, identical to the pulse timing in the December signal. A match. Timing accuracy, plus or minus 0.003 seconds. That removed coincidence from the equation. The main body kept moving outward, no longer accelerating. By March it crossed Jupiter's orbit. Juno measured a localized magnetic anomaly around the object, an induced field oscillating at 32 Hz, modulated, not chaotic. When plotted in 3 dimensions, the field lines formed a torus, symmetrical and persistent. Natural magnetism doesn't hold symmetry like that. Then the transmissions resumed. March 16, 2026, exactly at Jupiter encounter. Same hydrogen frequency. 3 minutes this time. Different content. Instead of prime number spacing, the pulses formed grouped clusters. 112, 123, 235, echoing Fibonacci again, but nested this time, like recursion. Sentinel-1 caught it on all 4 array sites. Phase delay between receptions allowed triangulation. Origin: the main body, not the companions. After that, silence again. The debate hardened into 3 camps. Naturalists: everything had a physical explanation, and the pulses were plasma oscillations coupled to solar wind flux. Instrumentalists: the signal was a self-checking diagnostic, a probe talking to itself. Contact advocates: the pattern was a deliberate test, phase 1 of an ongoing exchange. Governments leaned toward silence. Scientists kept publishing. Public imagination filled gaps faster than facts appeared. Then came April 7th. ESA's Hera probe, still coasting through the inner solar system, recorded a transient radar echo. It bounced off nothing visible. The echo had a perfect round-trip delay matching the path to 3I Atlas's lead companion. Except that companion wasn't in radar range anymore, it should have been too faint, too far. Yet the echo came back. Energy signature matched Inconel-type reflectance again. That night, the hydrogen line burst one last time. 1 minute flat. The pulse spacing reversed, primes descending instead of ascending. The final amplitude faded smoothly into background noise. No further signals were ever detected. By summer 2026, the main body moved past Saturn's orbit, faint and cold. The subobjects dispersed on divergent vectors. None reappeared. The Interstellar Response Coordination Office published its first and only full report that August. The summary read: 3I Atlas exhibited multiple characteristics inconsistent with known natural processes. Industrial alloy emission signatures, structured electromagnetic modulation, and controlled subobject deployment strongly suggest artificial design. Intent and origin remain undetermined. It was the closest any official document had ever come to saying the word alien. After that, the world adapted in strange, quiet ways. Astronomy departments exploded with applicants. Defense budgets shifted toward orbital surveillance. The Vatican issued a statement calling the event a reminder that creation is wider than comprehension. The stock market normalized. People went back to work. But the sky felt different. Every interstellar object detected after 3I Atlas carried an unspoken weight. 4I Borisov 2, 5I Nomura, 6I Katri. Each discovery triggered automatic sentinel scans. So far, no repeats. No signals. The hydrogen band stays silent. The nickel-chromium line, too. Yet telescopes keep watching. Because once the universe speaks once, you never stop listening. By 2030, Sentinel-2 launched, a ring of synchronized satellites forming Earth's first dedicated interstellar signal interferometer. Built to catch another whisper at the hydrogen line. Every second of every day, it records. No answers. Not yet. But everyone knows 3I Atlas proved something fundamental. The void isn't empty. Somewhere, someone, or something, sent a messenger once. Whether it was a greeting, a test, or a warning, nobody can say. And maybe that's the point. The message wasn't the transmission. The message was the mirror it held up to us. Now every time a telescope slews toward the dark, the question hangs in the data stream. Did we pass the test?